An emergency shutdown button should end the danger. At Chernobyl, pressing it probably helped drive the reactor into the surge that destroyed Unit 4. The button did not create the unstable reactor. During a turbine rundown test, power unexpectedly collapsed to about 30 megawatts thermal. Operators recovered it to roughly 200, but post-accident calculations put the operating reactivity margin at 8 manual control rods, below the required minimum of 15. The reactor was running low, distorted, and vulnerable. The RBMK had another dangerous property under these conditions, a positive void coefficient. As water turned to steam, the graphite moderator remained. Less liquid water meant fewer neutrons absorbed, so reactivity could rise. More reactivity made more heat made more steam. The feedback loop could accelerate itself. Now look inside one control channel. A fully withdrawn rod left a 1.25-meter column of water below its graphite displacer. When the shutdown began, graphite moved down first and displaced that water. In the lower core, this could briefly add reactivity before the neutron-absorbing section arrived. And full insertion from the upper stop took 18 seconds. The safety rod began with the wrong material. At 1:23:40, the emergency protection command was pressed, and the rod started moving. 3 seconds later, excursion alarms appeared and recorded power exceeded 530 megawatts thermal. The large RBMK core was not behaving as one uniform machine. Its upper and lower regions were loosely coupled. The positive scram could push the lower core supercritical, while the rods were still descending. The most disturbing part is that the positive scram hazard was not entirely unknown. A dangerous rod effect had been identified before the accident, yet the rods were not corrected, compensating measures were not imposed, and the warning was not effectively carried to operating crews. Early accounts blamed operators almost entirely. Later IAEA analysis shifted the picture toward a concurrence of design defects, operating decisions, poor procedures, weak information exchange, and deficient safety culture. Chernobyl was not destroyed by one button. It was destroyed when unstable physics, defective control rods, operating pressure, missing information, and weak oversight aligned. A safety system is a promise about what will happen in an emergency. If its real behavior is hidden, the promise is already broken.